Chapter 33, Fundamentals of Hydraulic and Air-over Hydraulic Braking Systems. Day 2, Video 10, Hydraboost. So this is the second means of boosting the brake effort from the driver. We use a Hydraboost or hydraulic boost. Before we used the vacuum booster, we could only use that on non-turbocharged or naturally aspirated engines. Now if we've got a turbocharged engine, turbo diesel in here, there is no vacuum in the intake system, there's only pressure, right? So we will not use the intake pressure to operate the Hydraboost. We've got the separate power steering pump or a separate brake pump to create that pressure. So we use principles hydraulic, so pressurized hydraulic fluid inside the Hydraboost to create the brake amplification, the brake boosting. Between the master cylinder and the brake pedal is where we're going to have that Hydrabooster located, and then again that separate power steering pump or power brake pump, a separate one from the system. So we're using a separate hydraulic system. And then they're going to have an electric backup motor. So first mode we've got is engine running, no brake application. My foot is off of the brake pedal. We're still creating that hydraulic pressure, but the valving inside of that Hydraboost directs that hydraulic pressure not to the piston, but around the piston, and just returns it back to the power steering pump unrestricted. No boosting action happens. Second mode, driver pushes down on the brake pedal, right? What it's going to do is direct that hydraulic pressure to one side of the piston. It's going to move the piston, creating the braking effort. Third mode, driver holds the brake pedal depressed at any point, and so what that's going to do is going to direct the pressure to the backside of that piston, causing it to move until we create an equilibrium between the pressure and the spring on the other side of the piston. And then it goes into a hold mode, no pressure in, no pressure out, or maintaining brake system pressure. And then lastly is the electric motor backup that we've got. So in here we're allowing the pressure to come in. We've got some valving in here that allows that pressure, when we make a brake application, pressure would come in and act on the back side of this piston, causing the piston to move out. And again, it's connected onto the primary piston on the brake master cylinder, and it's going to push it this way and help to apply the brakes. In our hold mode, you've made the 5 pounds of brake application pressure with your foot, right? 5 pounds of pressure is coming in, moving this piston this way until that pressure equals the spring. As we compress that spring, it's going to create more and more energy, more resistance until those equalize, right? And we've got some valving in there that shuts off the hydraulic pressure to this piston, and it maintains it at that 5 pounds of force on this side of the pressure, on this side of the piston. We've got spring pressure pushing back on this side of the piston, and they're equal. No pressure in, no pressure out. We're maintaining that 5 pounds of brake pressure. And then I release the brake pedal. The valving changes the pressure. We drop the pressure from this side of the piston and just reroute it back to the pump. The spring's going to move the piston, retract it, releasing the brakes. And then lastly, here's that electric motor. We have a failure in the engine stops running, and now I've got an electric motor here that's going to use battery power to spin a motor in here, creating the hydraulic pressure that we need to operate the boosted level of brakes. So as long as we've got voltage in the batteries, we can have this pump creating that pressure as a secondary or a backup system.